Hi, and here is another clip about empirical formula. I'd suggest go and watch the other one first before you do this one, just so you know what I'm talking about. So this is about empirical formula using percentages. So this is if the question's got percentages in it, how to do empirical formula. But as I say, you must watch the other one first, otherwise it won't make sense. I've got a lovely picture down here as well. If it gets a bit monotonous, you could look at the cat. But anyway, here we go. What is the empirical formula of a substance that contains 70% iron and 30% oxygen? Now this is how you do it. It's quite simple. You need a calculator and a pen. So I'm going to attempt with the pen on here. Oh, the calculator's gone. Right, here we go. So we do 70 divided by whatever the mass number of iron is. So the mass number of iron, looking it up, is 56. Okay, because that's on the periodic table. So I can go 70 divided by 56 equals 1.25. Marvellous. And then you do 30% of oxygen, so 30. Oh, you're having a bubble. Look at that, it's all gone a bit made. Let's do it properly. 30 divided by 16, because the mass number of oxygen is 16. Okay, stick that in a calculator. 30 divided by 16 equals 1.875. Now wait, it's doing the pen. 1.875. Now with empirical formula, remember these need to be whole numbers because we can't have FE 1.25. So to make it whole numbers, what we do is divide by the smallest number, which we did last time. So let's divide by 1.25. Now that means there is iron. This is iron, remember? There is one iron. I'll put it there just in case you know what I'm talking about. One iron. And then you divide this side by 1.25 as well, because whatever you do to one side, you've got to do to the other. And you end up with 1.5 if I stick that in a calculator. Now the problem is, again, we haven't got whole numbers, but we're nearer, aren't we? We're nearer. So what we'll do now is, if I double it, it's all trial and error. Get so far in the exam, it doesn't matter. You get some marks for whatever you do. So we'll double this, FE2, let's give that 2, and then double that, and then that's whole numbers, isn't it? Because that will be 3, and that's it, Fe2O3. So the answer to the empirical formula of a substance that contains 70% iron, 30% oxygen is Fe2O3, because you divide the percentage by that, the MR, or the AR in this case, and then again on this side. Work out the common denominator like that, and then you end up with Fe2O3. Another problem you might come across is this, the molecular formula from an empirical formula one. Oh my goodness, it's all going pear-shaped. Now I've got a nice frog for you. Right, what is the molecular formula of a compound with the empirical formula CH2, which has a formula mass of 70? Oh my goodness. Right, for this you need to go CH2 and look up the MR. Remember how to do that, it's the top numbers, add them together. C is 12, H is 1, and there's 2 of them, so add that, is 14. Okay, so the MR of CH2 is 14. Okay, now you've got 70, and this is only 14, so you do 70 divided by 14. Hang on quick, 70 divided by 14 equals 5. So you've got 5 lots of this. So it'll be C5H10. Because look, 2 times 5 and 1 times 5. So that be the answer. I think I'm going to give myself a smiley for that. Look. Oh, fab. That's good, isn't it? Anyway, so that's how you work out the empirical formula from the molecular formula. And that's how you work out empirical formula from percentages. The tricky bit is finding out, you know, the common bit, the common number to try and get it to whole numbers. But don't worry too much about that, as long as you can do this.